Okay, so these equations are going to take a little bit of space, so I'm going to kind of have to work with the slide a little bit. So bear with me as I have to erase some things and move the worksheet over there. So here we can use calculators if it's needed. We have the log base 2 of the fourth root of x minus 1 plus the log base 2 of 6 equals 5. So I have the log base 2 and the log base 2 with addition. I could use my product property. So that's the log base 2 of 6 times the fourth root of x minus 1 equals 5. Doesn't multiplication is commutative, so I can put the 6 in front, then it just looks better. Now I can rewrite this as a log 2 to the 5th, or I'm sorry, rewrite it as an exponent, equals 6 to the 4th root x minus 1. 2 to the 5th is 32, is the 4th root of x minus 1 times 6. I'll divide it by 6. So the 4th root of x minus 1 equals 32/6, which reduces to 16/3. So let's write that as 16/3. I just divided by 2 to reduce my fraction, because I'm going to raise that to the 4th power to get rid of my 4th root. And I get x minus 1 equals, let's see, 16 to the 4th power. Let's break out a calculator on this one. So 16 to the 4th power is 65,536 over 81. And we're going to add 1 to both sides. So I get 65,536 over 81 plus 81 over 81. That's adding 1. And as an exact answer, 65,617 over 81. Or if I get a decimal approximation, approximately 810.09. So a little bit of calculator on that one. Number 12. 2 times 3 to the x plus 7 equals 17. So I'm going to start by minusing 7. So 2 to the times 3 to the x equals 10. Divide by 2. 3 to the x equals 5. Now I can log both sides. I can log base 3 both sides. I can rewrite it as a log. So in the spirit of just trying different methods, let's take the log base 3 of both sides. So log base 3 of 3 to the x equals log base 3 of 5. Log base 3 of 3 to the x is x. And the log base 3 of 5, to do in my calculator, I have to do log 5 divided by the log of 3. So I end up with the same thing no matter how I solve it. So log 5 divided by log 3 in my calculator is 1.465. X is approximately 1.465. And you really should be using the squiggly equal sign as soon as you make it a decimal approximation. All right, so I got to move the slide over. So if you still need to copy, I would pause it. Okay, we're going to look at number 13 now. Log base 6 of x equals -2. We're going to solve this by, let's do exponentiating just for the fun of it. Let's make that 6. I'm choosing to make the base of the exponent 6 because I have a log base 6. And I know the log base 6 or 6 to the log 6 of x is just x. And that equals 6 to the -2 power. And x equals 1 over 36. I've got to love those short problems. Number 14. Get rid of my 2 first. 4 to the 3x equals 9. And let's see, let's common log both sides. So I got the log base 4, 3x comes out front. So 3x log of 4 equals the log of 9. And we'll divide by, kind of interesting, can't I rearrange this? Let's think about this before we work too hard. can't I rearrange this to x times 3 log of 4 equals the log of y of 9? The only thing I did was switch the order of the x and the 3, which looks funny, but when I see it this way, now I see that I'm dividing by 3 log 4. Divide by 3 log 4. And then it's just calculator work from here. Okay, so my exact answer is log 9 divided by 3 log 4. Make that look like a 9, which is approximately 0.528. Okay, once again, I'm going to move the slide around, so pause it if you need to continue writing down. We're going to number 15 and 16 now. Number 15, log 3 of x plus 4 plus log 3 of 2x equals 6. Here I have a condensing problem with addition, so I'm going to make it multiplication. Log 3 of x plus 4 times 2x equals 6. And that's the log base 3 of 2x squared plus 8x. I'll distribute that, equals 6. I'm going to rewrite this as an exponent. 2x squared plus 8x equals 3 to the 6th power. So it's 3 to the 6th. Gives me that side. And 3 to the 6th power is 729. So 2x squared plus 8x minus 729 equals 0. So that 729, I subtracted it to the other side. And now we want to solve this. Let's see if we can factor it. 2x and x. 729 is, so it's 8 times 9, 81 times 9, or it's 27 times 27, but those aren't going to get us 8. So what I did was I looked at decimals, and I saw that it doesn't cross, it crosses at decimals, so I don't really want to deal with it, so I'm going to use quadratic formula now. Actually, I could complete the square. Let's complete the square. I think I'll deal with less large numbers that way. So let's go back to putting that on the other side of the equal sign. So I'm going to erase this and make it equal to positive 729. I have to divide everything by 2 in order to complete the square. So it's x squared plus 4x equals 729 halves. And when I take 4 and divide it by 2 and square it, I get 2 squared, which is 4, and that's the number that I need to add to both sides. So I'm going to add 4. I'm going to add 4. Oh yeah, this one isn't so bad. And let's see, let's come up to the top. I get x plus 2 squared, because that's how x squared plus 4x plus 4 factors. And that equals, that's 4 is 8 over 2, and 729 plus 8 is 737, so it equals 737 over 2. And then I'm going to square root both sides. And I get x plus 2 equals the square root of 737 over the square root of 2. And then I subtract 2, so x equals negative 2 plus or minus the square root of 737 times 2. These numbers are getting huge. And let's see, 737 times 2, 1474. square root of that over 2. And the square root of 1474, we're going for a decimal approximation at this point. 74, 38.39. And that's divided by 2. So we'll divide by 2 and get, oops, negative 2 plus or minus 19.196. So if negative 2 plus 19.6 would be 17.196, and negative 21.196. Oh, wasn't that a fun problem? And then something I've forgotten to do everywhere on the video so far is check for extraneous solutions. And the negative is going to be extraneous because when I plug it in, it's going to make a negative. So my only answer is 17.196. Let's take a peek at some of these other problems and see if it's a problem. The only problem on the log equations, number 13 is okay because it's a positive 1/36. And let's see, number 11 has 2 domain restrictions. One, the radical can't be negative, and what's inside the log. Since that won't be negative, it won't be. Since the radical can't be negative, we're okay. We got 810, which will definitely keep it positive. So I think we're good on that. All right, let's move on to number 16. Hopefully it's nicer than that last one. Natural log of x plus 3 minus the natural log of 4 equals the natural log of x plus 8 over 5. So minus, since I can write it as division. So the natural log of x plus 3 over 4 equals the natural log of x plus 8 over 5. And we have the logs equal to each other, so I can just equate what's inside using the one-to-one property. And I can solve this by using cross multiplication because it's a proportion. So I get 5x plus 15 equals 4x plus 32, and minus the 4x minus the 15, so x equals 17. And that keeps all my logs positive, so that works. Next problem, number 17. Oh, this is the doozy. 4 to the x plus 1 equals 6 to the x plus 3. So we're going to do the log both sides. Let's actually, on this one, because I didn't do this in any of the previous little videos I did, I'm going to actually use log base 4 here and show you that. So log base 4 of 4 to the x plus 1 equals log base 4 of 6 to the x plus 3. Now the benefit of using a log of a specific base is that we end up with only one real log factor here, and there's not as much distributing. The x plus 1 comes out front, or actually the x plus 1 is just log 4 of 4 to the x plus 1 is just x plus 1. But the x plus 3 here comes out front, and we get x plus 3 times the log 4 of 6. And x plus 1 equals x log 4 of 6 plus 3 log 4 of 6. And I'm going to subtract the 1 because these terms don't have an x. And then I'm going to move the x term so that I get those together. So I'm going to subtract x log 4 of 6. And on this side I get x minus x log 4 of 6 equals 3 log 4 of 6 minus 1. And then subtract or factor out an x, 1 minus log 4 of 6 equals 3 log 4 of 6 minus 1, and then divide by the 1 minus log 4 of 6 and 1 minus log 4 of 6. Now this one might be a little bit more cumbersome to plug in your calculator if you don't have the cheater key. Minus 1 over 1 minus log 4 of 6. So I'm going to use Desmos to evaluate this because the Desmos calculator actually does have the log base A. So I'm going to plug it in 3 log 4 of 6 minus 1, parentheses around that, divided by 1 minus log 4 of 6. And I got negative 9.838. So x is approximately negative 9.838. All right. I think we're in the home stretch of this worksheet here. We're going to go to the expanding and condensing. I'm going to clear everything else off of this. Okay, now we have some clean working space again. Rewrite as a sum of logs. The log base 2 of 4ab squared. So each of these have to be in their own separate log, the 4, the a, and the b. So my product property tells me my products can be written as addition. So I have the log base 2 of 4 plus the log base 2 of a plus the log base 2 of b squared. Now I know what the log base 2 of 4 is, don't I? Log base 2 of 4 is 2 plus the log base 2 of a, and my exponent becomes my coefficient, plus 2 log 2 of b. And that's my final answer. Next one, log base 5 of x divided by z square root y. Now the square root y is in the denominator. So both of those are going to end up being subtracted. So I have the log base 5 of x minus the log base 5 of z. And the square root of y is still in the denominator, so it has to be subtracted. Log square root of y. And then the square root is the 1/2 power, right? So we're going to get that as the log 5 of x minus the log 5 of z minus 1/2 the log of y. And number 20, let's see, the natural log of a times b squared to the third. Sometimes it might be easier to actually just distribute your exponent and look at it as ln of a cubed b to the 6th. And now I can make sure it all gets done right. Ln of a cubed plus, because they're being multiplied, ln of b to the 6th. My exponents become coefficients, so 3 ln a plus 6 ln b. And lastly, condensing. 2 more and we're done, I think. Yep, last 2. Okay, so number 21, 1/2 log of x plus the log of y minus 3 log of z. So multiplication or addition becomes multiplication, subtraction will become division. So this is going to end up in the denominator of my fraction. So I get my coefficients become exponents. Log of x to the 1/2 power times y. And we'll just write it as log minus log of z cubed. So in one step I did the exponent and the multiplication, and now I'm going to make it a fraction. The log of x to the 1 half y divided by the z cubed. And I can put that in parentheses. So when I'm rewriting it as a single log, I should not have the word log more than once in my answer. And lastly, negative log 2 of 1 over x minus log 2 of z plus 3 log 2 of y. So let's make this log of 1 over x, log base 2, to the negative 1 power, minus log 2 of z plus log 2 of y cubed. And that's just going to become log 2 of x, because when I reciprocate a fraction, it becomes the whole number, and minus the log of z. So, but what happens here is this is going to get multiplied, and this is going to get divided. So my y cubed is going to end up in the top, and my z is going to end up in the bottom. And my final answer is log base 2 of x y cubed divided by z.